Hello everyone, so I'm gonna solve today this problem, minimum number of days to make M bouquets. So basically what is happening, we are given one array, BloomDay, which is giving us the day at which the particular flower would be bloomed, and we are given M and K. So M is basically the number of bouquets we have to make, and K is equal to the size of every bouquets. So basically we have to make the bouquets out of these BloomDays filter that array. So there is one condition that the whatever size of every bouquet is, we have to have those flowers should be consecutive. Okay, so let's say if k equal to 3, then 1, 10 and 3. If we want to pick this, we have to pick all the consecutive 3, though weighting would be 10 here, because maximum on day 10 the third part all the threes would be available as they will bloomed. So similarly we have to make the total m such bouquets. So we have to basically find the minimum weight that we have to find so that we can complete the m bouquets of size k. This is all what I have to. So let me explain it in a proper way. So you can say here, if there are m bouquets in size k, so m into k, 3 into 2, so 6 flowers at least required. But see here, the size itself, there are only 5 flowers, okay, in the BloomDay. So in those situations we can directly say that if m into k is smaller, if m into k is greater than the size of array, let's say m into k is greater than n, where n is the size of array, then we can say that this would not be possible at all. Okay, so we can directly, what would be our answer? We can directly say that it would be written -1. Okay, so this is our very first condition that we have to check. Now consider this is not the situation, the size is greater than or equal to, then we have to form the bouquets and then we have to find the minimum weight, because there could be multiple solutions. Okay, here we could, let's say this array is very large, then there could be multiple m bouquets, okay, which are of size k. So we have to pick those which are producing the minimum waiting time. Okay, so for example, here if somebody is picking you 1, 10 and 3, let's say k is equal to 2, so 1 and 10. Okay, so waiting time would be here 10. If then somebody has to pick 3 and 10, okay, then again waiting time would be 10, but then it is 2. Okay, so let's say if m was only 2, then it would be a valid thing, because m into k would be definitely less than n. Okay, so in this case 2 into 2, 4, so that would be a valid thing. So in this case what would happen? So we have to, basically the answer would be 10, because everywhere we are at least waiting till 10. Okay, so we picked first this. Okay, so we done with 1 m. Now we have to make one more m. So we can pick 3 or 10, 3, 10 or 10, 2, right? But the maximum weight is still going here also 10. So basically our answer would be 10. Okay, so we have to find such kind of solution of it. Okay, so we have to find the minimum waiting time. So let me take some other example as well to make it more clear. So we can take another example. This is the one of the example. So see here, basically m equal to 2 and size is 3. So first of all we have to check 3 into 2, it is 6. So basically the BloomDay is greater than 6. So that should be fine. Actually its size is 7. So that is first check, and then we will see that basically we have to pick the 2 such bouquets of size k equal to 3. Okay, so see here, we can pick this one, okay, and either we can pick this one or we can pick this one, right? So see here, what would be waiting time here? So 7, 7, 7. So on day 7 all the 3 flowers are bloomed. Okay, so here it is 7. Now we will go to the next possibility. So either we can pick these 3 or we can pick the very last 3. So but here also, let's see here, it is 7, it is 12, it is 7. So maximum weight here, it is becoming 12. Okay, now even if we take the last 3, then also 12, 7 and 7. So maximum weight it is equal to 12. Now see here, we need only the 2, right? We need only the m equal to 2 bouquets. So we can make 3 bouquets, but see here, we have to pick at least 2. So 7 and 12, right? So max weight, even if we pick last two, then also the max weight actually becoming the minimum weight is still 12. Okay, on day 12 only it would be possible, then we can make the both the bouquets completed of size 3 with the consecutive thing. Remember that we have to pick the k consecutive flowers only. So here waiting time is happening 12, which is also the minimum waiting time. Okay, you can consider, let's say if instead of last 7 it could be 17 for example. Okay, then in that case what it would be, first of all we would put first so 7 7 7 we would, so waiting time is 7 here. Then we would put 7 12 and 7. Okay, so 7 12 and 7, again the most waiting time would be here 12. Now let's say if we were picking here 12 7 and 17, I just modified the last value. So 12 7 and 70 also could be one solution, but in this case the max time would be 17. So out of all these values, what is the max? Max is 17. So to complete m equal to total bouquets, we have to pick the maximum again, because we have to take only the two of them. So here again we would go to this only, we would not pick the maximum one, we would pick the 7 and 12. So because m is equal to 2 here, so in this case also it bars only the 12 only. Now consider this m was 3. Okay, if m was 3, what it would be? We already got the 7 and 12 and 17, right? So first of all it would not be possible at all, because see here 3 into 3, it is becoming 9, but its size is 7 only. Okay, so here in that case what would be the answer? In that case it would be -1. Okay, so now we will look for the approach of it. Right, so we will solve this problem using binary search. Now some of you might have a question that this BloomDay, this array is not sorted, then why this guy is saying that we will use binary search? So for sure I am not using my binary search directly on this BloomDay. Basically I am using my binary search in a hypothetical way, but I am taking the help of this BloomDay. Okay, so what is that hypothetical way is basically, consider in real situation. So BloomDay, this is an array of BloomDay. Consider we are taking the maximum value of it. Okay, so 10 is the maximum weight here, right? 10. So we can say that whatever is happening between 0 to 10. Okay, so start we can have like 0th day, and end could be the max. Max means max is the max of this array. So let me write down it here. See here, the maximum of this BloomDay is the 10. Okay, so anything which is starting from 0 till end equal to max. That is the only time where we have to find whether we are able to solve our problem or not. Okay, from starting point 0 till day 10, everything should be bloomed, whatever is there in the BloomDay. So everything should be bloomed. So now we have to start our binary search in such a way that we are starting with 0 and with max, then we can get the mid. So this mid is also some day. Okay, now we have to find in this BloomDay that till the end of this mid day, including this day itself, that how many bouquets we can make. Okay, how many consecutive bouquets we are able to make. Okay, and similarly we will look whether we have completed m or not. Okay, so let's say if we have completed the m bouquets, that means we have got the solution at this mid. Now our tendency should be to get the further smaller value even when we got a solution, because consider the situation that let's say on day 10 if something is completed, let's say on day 10 also, let's say on day 10 we are able to complete it, the total number of m. So there could be also a possibility that might be done on day 8 itself, right? If something is completed on day 10, that also might be completed on day 10, day 8, who knows, right? So we have to go left. On the other hand, if number of bouquets, m bouquets are not completed, then we have to go to the right side of it. Okay, so basically in this way we are basically using our binary search. We are not directly using the binary search on this BloomDay array, first of all. Now next thing is we have to write one utility function which will give that if we call that function on any day, okay, let's say any day D, then we have to find that till that D how many bouquets we can complete. Okay, so there is one utility function. So let's dry run of it. Let's say I'm giving day equal to let's say day equal to 10. Okay, so we have to check that till day equal to 10 how many bouquets we can complete it. So see here 1 to 10 and 3, one bouquet is here, right? Because 1 is also less than 10, 10 is also less than or equal to 10, 3 is also less than or equal to 10. So one bouquet is completed here. Then we have here 10 and 2. Okay, so till here it has, let's say we have one more value. Consider we have 10, 2 and 3. Let's say there is another value here, so that we will make the complete solution. So now in this case 10, 2 and 3. Okay, here also we can make one more bouquet. So total bouquet on day 10 we would be completed total bouquet 2, right? So now similarly, based upon these values, whatever output comes on when we call this utility function on the mid values, we will check whether should we go to the left side or should we go to the right side. If we have completed m bouquets, then we have to go to the left side. If we have not completed m bouquets, that means we need more flowers, and in that case we have to go to the right side of it. Okay, so for that reason we are using the binary search. We are not using directly the binary search on this BloomDay. So let me further run the exact code what we gonna do here. So see here, my start is 0 here, end is 12. Remember, I'm starting the max value of this BloomDay. So end is 12. Now my mid would be start plus end by 2, which is mid equal to 6. Okay, so see here what all days could be possible before day 6. Okay, so there is nothing possible because even everything is starting 7, 7, 7. So what would be the output of it? How many bouquets we would be completed? M, basically M is 0 because nothing is starting from 6 itself. Everything is starting from 7. So M is equal to 0. And how many M's we have to do is, basically we have M equal to let me check for how much it is. So see here in this question, M equal to 2 and K equal to 3. Okay, so here we can see so far we have created M equal to 0. That means we have to go to the right side. Okay, then right side we will go. Then what will happen? Our new start would be just like binary search. What would be our new start? Our new start would be mid plus 1, right? So this would be mid plus 1. So see here our start is equal to mid plus 1, which is 6 plus 1. Now it is 7 and end is still 12. So our new mid would be 12 plus 7 divided by 2, which is 9. Now we have to check that how many M we can complete before or till the 9th day. Okay, so see here we can pick this guy, right? Because this is done before 9. We can pick this guy because this is also bloomed. 7, this is also bloomed, right? So K equal to 3. So we can pick these 3 guys. So 1 M is done till here. Okay, because count is now 3, so 1 M is done. So now M equal to 1 we have. Now we will go for this, that this guy is also bloomed there, but 12 is not bloomed. Okay, so we cannot pick these 3, right? Because we need the consecutive, and this is 9 only. So see here, by end of this we actually find M equal to 1. Okay, so we found M equal to 1, which is less than M, so whatever value we have, right? We have M equal to 2, so which is still less. So we have to again go to right side only. Okay, so our new start and new mid would be, so let me write down it. So you can see here, so our next start would be mid plus 1, so that is 10, and end is still 12, so 10 plus 12 divided by 2, so our new mid would be 11. Now see for the 11. Okay, so for 11 also, when we start, see here, at the 11 we see here till here we are done, right? So we start from here. So look at the 11. If we give the 11, that this guy would be completed, 7A. Yeah, this also will be completed. This also would be completed. So one bouquet is there. So m equal to 1 here also, m equal to 1 so far. Now we will further increase here. So this guy is also less than 11, but 12 is not less than 11, right? It is 12. So again we are having only m equal to 1. So that means we have to again make our start to the right side only. Okay, so what would be the new values? New values would be start would be mid plus 1, which is 11 plus 1, right? So it would be 12 plus 12 because our end is still there. So 12 plus 12 divided by 2, which is 12. Okay, so our new mid would be our new mid will be 12 only. Okay, now for point 12 we will see that what happens. Okay, so again we will start from the very first. So we can pick 7, we can pick first 3 because both of them are less than 7. Similarly we can pick here also 7, 12 and 7, right? Because this is also less than 12, this is equal to 12, and this is also less than 12 because our mid is 12 now, right? We are calling this. So finally what we are doing in this case, our m equal to 2, right? So if we have got m equal to 2 and this is given in our answer, so if we have m equal to 2, then we will return this current mid. Okay, so this is our answer. 12 is our answer. So basically 12 is total waiting time what we have to do. So now this is our simple explanation. Now I will quickly write the code of it and will explain each and every line of it. So guys, see here, I have written one utility function, getBouquets. Okay, so this function is checking the same thing what we were doing. Okay, so whatever point, whatever day we are calling it, it will start to check that how many bouquets we can make. Okay, so see here we are starting with the for loop from 0 thing, and we are checking that whatever is valid point, okay, wherever the point is greater than or equal to BloomDay, we are basically increasing the count. Okay, otherwise if it is greater than, okay, if point is smaller than the BloomDay index, in that case we have to make the count 0 because we need the consecutive k, right? And if we are going to this else case, then our consecutiveness is breaking. So that is why I am resetting count equal to 0. Now I am checking whether count equal to k. If any way we have count equal to k, that means one bouquet we have completed. So that is why I am increasing the count of bouquet, num of bouquets plus plus. Okay, and then resetting the count equal to 0 for the next k elements. So similarly, when we will come out of this, we will get the number of bouquets completed on day point which we passed. Okay, now this function, this utility function, I'm gonna use in my binary search method. Now see here, this is my binary function, minDays. Okay, so I'm taking BloomDay, int m and int k. So first of all, I'm checking whether m into k is greater than, in the case if BloomDay length itself is smaller than m into k, that means there are not sufficient number of flowers itself, then we are returning -1 because that there would not be a possibility of making that. Otherwise what we are doing, first of all, see here, I am getting the maximum value from the BloomDay, the maximum day on which everything would be bloomed. Okay, so after getting this, I am basically for binary search, I am assigning end equal to max and start equal to 0. I am initially putting this minDay as -1. Okay, so now see here, we are using the simple binary search here. While start is less than or equal to end, I am checking this, I am making this mid, and then I am calling this function getBouquets, the number of bouquets on this mid. Okay, so see here, if it is greater than or equal to m, then what we are doing on minDay, I am assigning equal to mid, and end equal to mid -1. We have to go to further left side because there could be a possibility of getting further smaller day. Okay, because we are looking for the smallest number of waiting time. So that is why we are going to the left side. Otherwise, if it is not equal to, if it is less than m, like we were going in our example, then we are going to the right side of it. And finally, we are returning the minDay, which is basically our answer. So let me execute this code. So yeah, I am running this code. It is working fine. Let me submit as well. Yeah, so it is accepted. And so thank you for watching the video, and if you have any concern, please make a comment. I will definitely come back, and thank you for watching the video.